Hello everyone, this is Heliok here. Today I welcome you to my show Computer Wednesday. Now in this show we're gonna take a look into the fascinating science and technology that goes into almost magical device that we call computer. So come along for the ride. So today is episode 1. In today's episode we're gonna take a look into how and where we can find computers. So these are the two topics that we're gonna take a look into. So it will be easier to understand if we start understanding these things in layers, as they have multiple layers of operation. So let's look at the basic layer that we are familiar with. For example, we are very familiar with the idea of there being a input, there being a memory, there being a processor, and then there being an output, whatever it may be. Now these are the most basic aspect of it. Now let's look into the processor. That's the bread and jam of everything. So let's look into it. Now processor, what does it actually do? It's very simple in principle of operation sense. It takes input, you give it a command to do something to that input or calculate something based on it, and it gives you an output. Basically it's a calculator where you tell it what to do, and that's why you many times in some circles hear the word computers are adding machines, and they are not wrong. It is on a very fundamental level. So that's what processor takes the information, processes it, and spits it out. Memory is there to record the information. So how does it do that? Like, is it magic? No. So let's go one layer deep. Now if you go into this layer, be mindful, it starts to get a bit more complex, and this is why computers at their fundamental level is so big. Now big in terms of number. So what we have is called logic gates. All computers that you see are built on logics. So they have logic, and logics can be so many varieties, so many types, and some examples are here, and or things of that nature. So these logic gates are what does the processing. So either A is greater than B, either A is equal to B, something of this nature. It's very simple arithmetic on a very basic level, and the level I'm saying basic, it's so basic it's literally runs on or off. So it goes to that level when you have logic gate. Now you might say, okay, I get the idea, there is a logic gate that is doing the addition, subtraction, comparison, or things of that nature. How does that work? Now this is the deepest layer that we can go into of computers, and that is the transistor. That's the core aspect of a computer. That's why you need a freaking PhD to design those things. And transistor in basic sense is just a simple switch which you can control on or off based on a signal. Basically it has 3 pins, and you tell it like, okay, either it's gonna be connected or disconnected based on the signal that is going into its 3rd pin. And this is why you heard the word, you keep hearing the word like it's running on binary, it's running on binary, because that binary signal, that 0 1 on or off, is coming from this transistor. The aspect of that transistor is very simple. It's like, I'm a switch which can be controlled, nothing more than that. You could design a computer at having a large switchboard, but suffice to say you're not gonna get even to a calculator level. So because binary, even if you to store a simple digit like number 8, number 10, you might need multiple binary codes just to store what that means. So we need something that does that on off, and the faster they do the on off, the quicker our computer gets. That's why we have gigahertz. Now to understand gigahertz, here's a scale, and in simplest sense, all it is just how fast it's doing its cycle. There are it takes a data, process it in a cycle, and then does multiple times that. It cannot just take a data, think on it, and then process it, and then come up with an idea, then recalculate it. It does it in cycles, and if you program it right, it does the right thing. If you program it wrong, it does the wrong thing. On the deepest level, so we have transistor. On top of that we have gates, logic gates. On top of that we have what you and I refer to as computers or processor for this instance. So that's how. And full disclosure, computers are as close to magic as humans have ever gone. To put things in context, computers have literally taken centuries of human knowledge, innovation in science, physics, chemistry, quantum mechanics, and everything that you can think of, including lasers, to freaking make them. Like, they are the most complex things we ever create. Literally, they are so complex they will make rocket science look easy. And I'm not joking about that. Like, rocket barely has few thousand things, and a normal processor like this processor, they could have somewhere as little as millions to as high as billions, and we are still keep going higher and higher. So as you can see, like the simplest level, it's quite simple. It's just a transistor that makes a logic gate. That logic gates are connected in an interesting way that gives us the language that we use. I mean binary language that we use. Then you have a compiler, then you have a lot of other things. This is starts to get complicated. This is why when you hear somebody studying computer science, this is what they are studying, how this logic gate layer interacts with the software. And this is the core level. Like, if you understand this, you can actually make a computer. So aside from it being magical, then comes the question, okay, it's a magic, almost. Where is it? So suffice to say that we all know it's everywhere in our day-to-day life. We know our smartphones, our smartwatch, everything has it. Now, I'll give you some simpler examples of this. A washing machine. Yes, that also has computer in it. Now, I specified the computer has a very simple operation. It takes data. Based on what you have told it, it processes it and gives out a useful result. So why a washing machine would need something like that? Very simple. Let's say you put clothes on your washing machine in auto. Wherever you see the word automatic washing machine or auto, this is what they mean. Whenever you put clothes on the drum of a machine, it runs the motor. There could be other methods also. So it runs the motor, it already knows what a blank drum should weight. So programmers will program it. Okay, so if it's empty, the motor should take this much current. So it's like, okay, let's say 1 amp, it's like motor is running on 1 amp. So you put clothes in, now it takes 1.5 amps. So it knows that it has a load of 0.5 amps. On that, some engineer would have pre-calibrated it. It's like, okay, if you detect 0.5 of amps and somebody has told it that it's washing wool, use this much water, so it will keep the tap open for this long, and it will wait until it will run. Once the water is full, it will run it and see whether it's matching the criteria. If it's not, let's say the flow of water is too little, it will open the valve for longer. And as you can see, so suffice to say, even our day-to-day life, something as simple as washing machine can have use and need computers to make it more effective, more efficient. Something as simple as a battery charger, like a lithium-ion battery charger that I'm gonna use for this DSLR, or you might have in your phone and phone chargers. They also have a lot of computing power into them. Not a lot, but they have computation in them. What they do is, like, based on the voltage, they calculate what is the state of charge, so they don't blow it up. Lithium-ion battery really does not like to be overcharged or over discharged or anything to it. It just explodes. It just has a tendency of blowing up. So the sole reason we can use lithium ion nowadays so effectively with our mobile phones and car is that we figured it out how they work based on microcontrollers and microprocessors. Now, microcontroller and microprocessor are just the same name of computer. It's just that what we nowadays have is very advanced computers. It's like the general purpose computer that we have nowadays that I'm gonna edit this video on, or you're gonna use a smartphone to watch this video on, or something like that, is so advanced nowadays that, to make it simple, we call simple circuits that are either in camera lens for vibration correction or reduction, or in battery chargers, we call them microprocessor, microcontroller, things of that nature. So if you see like something equipment, electrical equipment, saying like, this lift is microcontrolled, or this lighting has computer control, that's what they mean. They have a processor that they programmed, and it does the thing that it needs to do at that time. So where are computers? Well, everywhere. including inside us. If you have any implant, as simple as a pacemaker to something more complex like an insulin pump or a hearing aid, all of them have computers in them, especially given the fact that conditions can change. So you cannot just run these things on simple clock system, like, okay, clock, do this. It won't. Like a heart is a complex system, our hearing system is a very complex system. All those things considered, we need computers to make our life better. So as you can see, it's literally and figuratively everywhere. So let's call it a day today, and we're gonna discuss more about this in episode 2. And I hope you enjoyed it. Thanks for watching, and I hope you to see you next time. Thank you. And if you like the content, please like, share, subscribe, and press the bell icon, because I upload video every weekday. So thank you.